Welcome back to this channel. We are still in chapter amine, and this video we will focus on the chemical properties of amine. What we're going to focus in this video will be the Hinsberg test, nitrous acid test, and also the bromine water test, which is specifically for the aniline. And then we also will discuss the formation of dye through the coupling reaction. Before we discuss detail for the Hinsberg test, so we need to identify the reagent first. So we have two ways to carry out the Hinsberg test. One is we added both benzene sulfonyl chloride together with excess KOH to produce the salt, and then followed by the HCl. So the other way is going to use three steps. First, react with the benzene sulfonyl chloride to produce a precipitate. Then next, getting on the KOH. So that means for the yellow one, we combine together so that you no need to draw the structure for the N-substituted benzene sulforamide. Okay, so after react with the KOH, then on it followed by HCl. So now let's look with the details one. We are going to use the three steps to get the observation. So for the primary amine, we will taken out the hydrogen, while from the benzene sulfonyl chloride will taken out the Cl, and where basically you will get this benzene sulfonyl amide and also the HCl. So this one is considered as precipitate, and this precipitate consists of one acidic hydrogen, and as we know, KOH is a base. So when acid and base react to each other, they will going to produce the salt. So because of K potassium is a metal, so they always will add the form of ion. So here we will have K plus and nitrogen minus. So means that the hydrogen from the benzene sulfonide amide will react with the OH from the KOH to form H2O. So then now we have the salt will react with the HCl to produce the insoluble salt, which is considered as precipitate. So at where you will notice this structure is similar with this one. Okay, so that the K plus will replace back with the acidic amide hydrogen. Okay, basically the reaction happened at the secondary amine also the same. From the secondary amine will taken out the hydrogen, and benzene sulfonyl chloride will taken out the Cl, which will also produce an insoluble salt, or we can just label as precipitate. So however, different from primary amine, secondary amine after react with benzene sulfonyl chloride, they will have no acidic hydrogen. So therefore, they will not react with the KOH. So we can skip the part of the KOH. Okay, so they just combine together. So we will get the water insoluble salt. Then, like just now we say, after react with the KOH, the precipitate will react with the HCl. So again, there is no K plus in the precipitate here. So that's why no reaction will be going happen. So we will see no observable changes, or we can also write down the precipitate remain unchanged. Tertiary amine basically will not react with benzene sulfonyl chloride because there is no hydrogen at the secondary amine. So even though you add in the KOH, so some more KOH is base, tertiary amine also is base. So base and base basically there is no reaction, and they will form two-layer solutions. Okay, So, and then you will add on the HCl. Just reminder again, HCl is a very common acid which it will react with the tertiary amine to form a soluble salt, which is the clear solution. Okay, just do a very quick summary for the Hinsberg test. So Hinsberg test basically is used to differentiate the different classes of amine because all the three primary, secondary and tertiary amine have different observation. Okay, then normally we will combine the checking the amine with the benzene sulfonyl chloride with KOH in one step. And then after that, we will record the observation, then only we will add on the HCl. So as the primary amine consists of the acidic hydrogen, so it will form soluble salt. Okay, this acidic hydrogen able to react with KOH to form clear solution. And then when you add in the HCl, the clear solution will react with HCl to form the precipitate. So for the secondary amine, because they have no acidic hydrogen, so you will keep getting the precipitate. Even after that you add on the HCl, they will also form precipitate will be remain. For the tertiary amine, when you react with the benzene sulfonyl chloride in excess KOH, because both one tertiary amine has no acidic hydrogen as well. Then, tertiary amine has no hydrogen, so that's why they cannot react with the KOH. So when cannot react with the KOH, so at the same time, the tertiary amine also is the base, KOH also base. So base and base will not react, so there is no reaction. You might see there are two layers solution is formed. But after you add in the HCl will react with the tertiary amine to produce, because tertiary amine is base, HCl is acid. So acid and base react will produce the salt, and this salt is soluble salt. Then you will see the observation is clear solution. Okay, then now let's continue with the tutorial question number 8. So in the previous video, we already able to identify the compound R. So now let's read this statement, continue with the statement. So when X is mixed with alkaline solution benzene sulfonyl chloride, so come out in our mind is the Hinsberg test. Okay, a precipitate U does not dissolve upon acidification. So the acidification here is referred to that it will react with the HCl. Okay, so from here we will have the idea that the compound X is the secondary amine. So this secondary amine possesses of 3 carbon. So as we know, if we have tertiary amine, nitrogen always have 3 bonds with 1 lone pair. So 2 of the 3 bonds here will bonded to carbon. Overall, we have 3 carbon. So if we want to separate them to 2 groups, means one will have 1 carbon and the other one will have 2 carbon. So another bond will bonded to the hydrogen. Okay, and then they react with benzene alkali solution of benzene sulfonyl chloride. So you can draw the structure benzene sulfonyl chloride, and then it's in the excess KOH. So as we know, the secondary first step, the H from the amine and the Cl from the benzene carbonyl chloride will be taken out, and then we will have the benzene sulfonyl and then connected to nitrogen. and this nitrogen will bonded to CH3, and another bond will bonded to CH2, CH3. So here there is no acidic hydrogen. After the secondary amine react with the benzene sulfonyl chloride. So this is the precipitate U, and this is the structure for the S. And then will not undergo does not dissolve upon acidification. So basically I think we already finished for this question. Okay, then now we can proceed to compound T. Compound T form two layers when mixed with alkali solution and dissolve upon acidification. So when dissolve means that we are going to get clear solution. So in other words to say, this is the observation for tertiary amine. So when T is a tertiary amine, as usual, we know that we need to draw the nitrogen with 3 bonds and then 1 lone pair. Since it is tertiary amine, means that all the 3 bonds must bonded to alkyl group. So we have 3 carbons, so it is very fair. Each bond will going to have 1 carbon, which is the methyl group. So this one definitely will be the structure for T. Okay, we already done for the Hinsberg test. So before we go to the nitric acid test, let's come with a simple chemical test or identical test for the aniline. So similar with the phenol, aniline also will react with the bromine water. So basically we can write down the equation like this. Aniline is the NH2 attached directly to the benzene ring, and then bromine water Br2 aqueous. So similar with the phenol, the bromine will attach to the 2, 4, 6 and will form white precipitate. So the Br, which replaces the hydrogen, will form the HBr. Okay, so this basically is the chemical equation that we can use to test for the identification test for the aniline. So now let's proceed to the tutorial question number 10. We need to suggest a chemical test to differentiate the following compound, and we need to give observation and also equation. So let's start with question number 1, ethanamine, from the word ETH. So we know that they have 2 carbon and then bonded to nitrogen. So will be HH with 1 lone pair, CH3, CH2. So this is primary amines. And then another one is aniline. So this is primary aromatic amine. So as you know, maybe you will think that we can use the Hinsberg test. However, the Hinsberg equation is much more complicated if we compare with the identification test of the aniline. Okay, so for this one, I think we will use identification test for the aniline, which will going to use the bromine water. Okay, so the name of the test can be mentioned as bromine water test. Okay, so bonded NH2, and then we write down bromine H2O, and then with 2,4,6 tribromoanidine, which is with the HBr. So equation got mark, reagent got mark, name of the test got mark, and then white precipitate got mark. Okay, when you are going to discuss about the chemical test for 2 compounds, so definitely don't forget about the CH3, the ethanamine. Just write down the structure and then as same as well, write down the bromine H2O, and then here you can mention, because we know the positive result is white precipitate, so here we can mention no white precipitate is formed. Okay, so another one for the another one mark for the equation of ethanamine. Okay, now continue with question 10b. We have N-methyl ethanamine. So let's draw the structure. We have a nitrogen with 3 bonds. One bond bonded to CH3, and then another one we have ethanamine, which consists of 2 carbons, so CH2, CH3, and then here 1 hydrogen, lone pair electron. So this is the secondary amine. And then another one we have nitrogen as well, 3 bonds. 2 bonds are bonded to CH3 because dimethyl, and then for the parents also consists of 1 carbon. So this is the tertiary amine. So up to here we only learn 2 chemical tests. One is Hinsberg test, and the second one is the identification test for the aniline. So it is very obvious there is no aniline in question B. So means that we are going to react with the Hinsberg test. So when we have the Hinsberg test, so first we will react the secondary amine with the benzene sulfonyl chloride. So as we mentioned, the H from the secondary amine and the Cl from the benzene sulfonyl chloride, they will react each other to form CH3 and CH2, CH3, and then bonded to S sulfonyl benzene. Okay, so this one is a precipitate. So if this precipitate continue react with KOH, because there is no hydrogen at the nitrogen here, so the reaction, there is no reaction happen. So it will be same CH3 and lone pair CH2 CH3, and also S double bond O sulfonyl continue with the benzene ring. So and then the next one, it will react with the HCl. So this one also precipitate. So the HCl also will not react with the benzene this precipitate the insoluble salt. So that's why the structure will maintain the same, nitrogen with lone pair CH2 CH3, and then sulfonyl chloride. This is oxygen, this one also oxygen. Okay, so this one is still precipitate. So generally we can see that the observation all over here, 3 step is precipitate. Okay, precipitate, precipitate, and precipitate remain. Okay, then now we continue with the N,N-dimethylmethanamine that we mentioned just now. N,N-dimethylmethanamine is a tertiary amine. So this tertiary amine, when react with benzene sulfonyl chloride, followed by the excess KOH. So since I already know there is no reaction, so I can combine these 2 steps together and then write down 2-layer solution is formed. Okay, which then next one we will react with the HCl. So the HCl will react with the tertiary amine. So the lone pair electron will donate to the hydrogen. So and then to form Cl. Okay, so basically, or you can just roughly draw like this. since the nitrogen have 4 bonds, so it will become positively charged. Okay, and then the or you can just draw like this, positively charged, and then we will have the Cl, which will be Cl negative. So here we will write this. So when the base and the acid HCl react, it will get clear solution.